When we multiply two complex numbers, we can use the box method, the same grid strategy you may have used for multiplying polynomials. It keeps every term organized so nothing gets missed. Our problem this time is 4 plus I times 3 minus 2I. We set up a 2 by 2 box. Across the top, we place our first factor, 4 in the first column, and I in the second. Down the left side, we place our second factor, 3 in the first row and negative 2I in the second row. Now we fill in each cell by multiplying the term at the top of that column by the term at the left of that row. Top left, 4 times 3. That gives us 12. Top right, I times 3. That gives us 3I. Bottom left, 4 times negative 2I. That gives us negative 8I. Bottom right, I times negative 2I. That gives us negative 2I squared. Now we have all four cells filled, 12, 3I, negative 8I, and negative 2I squared. Here's the step that makes complex multiplication unique. I squared always equals negative 1, so negative 2I squared becomes negative 2 times negative 1, which is positive 2. Now we collect everything. Our four terms are 12, 3I, negative 8I, and positive 2. Combine the real parts. 12 plus 2 gives us 14. Combine the imaginary parts. 3I minus 8I gives us negative 5I. Our final answer, written in a plus bi form, is 14 minus 5I. The box method and FOIL always give the same answer. The box just makes it impossible to lose track of a term. Set up the grid, fill every cell, replace I squared with negative 1, then combine.